Now let us discuss this problem. How many times a fair coin must be tossed in order to ensure that in 90% of the cases the observed ratio of the number of heads to the number of tosses will be 0.4 to 0.6. Here we are tossing a coin. When we are tossing a coin, we will get either head or tail, and we can toss the coin any number of times. We want to find that number of times, say n, for satisfying this relationship. So let us say, let x be the number of heads obtained in tossing n times. And we know that P of x, probability of getting x is 1 by 2. Again we know that since x have only two possible outcomes and we have discrete number of trials, x follows a binomial distribution with the parameter n and p, where p is the probability of success and n is the number of trials. Here p is 1 by 2 and n is unknown. We want to find n. P equal to 1 by 2. So we can rewrite x as x follows a binomial distribution with the parameter n and 1 by 2. Then, now let us come to our question. What is that? We want to find n to satisfy some condition. What is that condition? Ensure that in 90% of the cases, the observed ratio of the number of heads to the number of tosses will be 0.4 to 0.6. So what is the ratio of number of heads to the number of tosses? Is x by n. So we are interested in x by n. And we can rewrite the condition as P of 0.4 less than or equal to x by n less than or equal to 0.6 is ensure that 90% of the cases. So it is more than or equal to 0.9. Here we have an inequality that is greater than or equal to 9. And we are unaware about this nature of random variable x by n. So we are approaching Chebyshev's inequality for solving this question for finding n. For applying Chebyshev's inequality, we need to find the mean and variance of the random variable x by n. So let us calculate the mean and variance of the random variable x by n. So mean of random variable x by n is e of x by n, that is 1 by n, e of x, that is 1 by n into, what is e of x? X follows b and p, so it is np, that is p, which is equal to 1 by 2. That is mu equal to 1 by 2. Variance of x by n is equal to 1 by n square. Variance of x, that is 1 by n square. Since x follows a binomial distribution, variance of x is npq. That is equal to 1 by n into p into, what is q? Q is 1 minus p. So that is equal to 1 by n into 1 by 2 into 1 minus 1 by 2. That is 1 by 4n. Therefore, Standard deviation of x by n is 1 by 2 root n, which is equal to sigma. Therefore, we have mu equal to 1 by 2, sigma equal to 1 by 2 root n for random variable x by n. We have this condition p of 0.4 less than or equal x by n less than or equal to 0.6 greater than or equal to 0.9. So, the appropriate Chebyshev's format for this inequality or for this lower bound is p of mod x minus mu less than or equal to t sigma greater than or equal to 1 minus 1 by t square. Here mu is 1 by 2, sigma is 1 by 2n and random variable is x by n. For mod x minus n minus mu instead of mu 1 by 2 less than or equal to t into 1 by 2 root n greater than or equal to 1 minus 1 by t square. And given that p of 0.4 less than or equal to x by n less than or equal to 0.6 greater than or equal to 0.9. Now we are trying to rewrite this expression similar to Chebyshev's expression. For that one we need x by n minus 1 by 2. So we are going to subtract 1 by 2 from 0.4, x by n and 0.6. So p of 0.4, what is 1 by 2? That is, let us write 1 by 2 less than or equal to x by n minus 1 by 2 less than or equal to 0.6 minus 1 by 2 greater than or equal to 0.9. That is p of 0.4 minus 0.5 less than or equal to x by n minus 0.5 less than or equal to 0.6 minus 0.5 greater than or equal to 0.9. That is p of minus 0.1 less than or equal to x by n minus, if you want we can write this 0.6 or 1 by 2. So let us write 1 by 2 less than or equal to 0.1 greater than or equal to 0.9. We know that if minus a less than or equal to x less than or equal to plus a mod x less than or equal to a. Therefore, we can rewrite this x by n minus 1 by 2 as p of mod x by n minus 1 by 2 less than or equal to 0.1 greater than or equal to 0.9. Let it be equation number 2. Comparing 1 and 2, we can write t into 1 by 2 root n is equal to 0.1. And 1 minus 1 by t square is equal to 0.9. Therefore, 1 minus 0.9 is 1 by t square. 0.1 is 1 by t square. T square equal to 1 by 0.1, that is 10. T square equal to 10. Therefore, t equal to root 10. Applying this root 10 here, root 10 into 1 by 2 root n is 0.1. That is root 10 by 2 into 0.1 is root 10. Squaring this expression, we have 10 by 4 into 0.01 equal to n. That is 1000 divided by 4 equal to n, that is 250. So how we can write the result? The least number of tosses required to satisfy the given condition is 250.